In this video, we're going to look at finding the derivatives of implicit functions. An implicit function is a function that involves multiple variables, x and y. So an implicit function has multiple variables, and generally the variables are on the same side of the equal sign. As you look in example 1 and example 2 here, you can see that the x and y are on the same side of the equation. And a lot of times an implicit function, you may not be able to solve for y. And that's the difference between an implicit function and an explicit function. An explicit function are functions that you're generally used to dealing with. An explicit function means you can solve it for y. You can get it in the form y equals something. So an implicit function may not be able to be solved for y. So example 1, find the derivative of x squared plus y squared equals 1. I hope that you recognize this. This is the equation of a circle with a radius of 1 centered at the origin. All circles are implicit functions. If we tried to solve for y, we would have to subtract the x squared over, and then we'd have to square a root. So when you square root, you have to add a plus minus in the front. So a circle is not actually defined by one explicit equation. It actually takes two equations. The positive radical gives the top of the circle. So the positive radical is the top of the circle. And you need a negative radical to give you the bottom of the circle. So this function actually takes two explicit equations to define, which is why it's better to use the implicit function x squared plus y squared equals 1. Okay, so we want to find the derivative of x squared plus y squared equals 1. Something that you have to keep in mind is x is a variable, but y is a function. Y is the same thing as f of x. Y is a function, okay? And there's a difference here. The derivative of the variable x, so the derivative, remember d over dx means derivative, the derivative of x is 1, but the derivative, d over dx, of y, or f of x, so derivative of f of x, is f prime of x, okay? So we could also say that the derivative of y is y prime, and you'll see it written that way a lot. The other way you'll see it written is dy over dx, okay? And that's what I'm going to use in this video. So to find the derivative of this implicit function, you want to just find the derivative of each term. X squared, the derivative of x squared is 2x plus, so y squared, again, you have to treat that as a function. So what you're really asking here is, what is the derivative of a function squared? So you have to think chain rule with this. So y squared, you're going to deal with the squared first. You're going to bring down the 2, and you're going to keep the inside. So that becomes 2y. But then you have to say times by the derivative of y. And so in this case, I'm going to use the form dy over dx. And then you say equals, well, the derivative of 1 is just 0. Okay, so once you set this up, the goal is always going to be to get the dy dx by itself. So the first thing I need to do is subtract the 2x over to the other side. So I have 2y dy dx equals negative 2x, and then to get the dy dx by itself, I'm going to have to divide this 2y over. So dy over dx is equal to negative x over y, because the 2's will cancel out. And so this is the derivative of the circle x squared plus y squared equals 1. So let's try another one together, because I know this is completely new for us. So now we want to find the derivative of x times y equals 1. So you got to think of this. This is x times y. You got to think product rule. So the first function is your f, so x is your f, and the second function is your g, so g is y. So f prime is going just to be 1. Remember, derivative of x is always 1. But g prime is going to be dy over dx. Y is a function, not a variable. So y could really be anything. So we're going to set up the product rule. So we're going to do 1 times y plus x times dy dx. And then you say equals, well, the derivative of 1 is just 0. So again, the biggest thing that people forget when they're doing implicit differentiation is that x times y has to be solved with the product rule. And then the goal is always to get the dy dx by itself. So I'm going to minus the y to the other side. So I have x dy dx equals negative y, and then I'm going to divide this x over. So dy over dx is equal to negative y over x. And generally, you'll notice both in example 1 and example 2, the derivative still has an x and a y in it. And that's generally what's going to happen with an implicit function. All right, in example 3, we want to take the derivative of sine of x squared y squared equals x. So this is a pretty complicated one. We've got to start with the outside function. The outside function is sine. So sine is going to turn to cosine. Leave the inside alone. And then we have to say times derivative of the inside. But in this case, the inside is a product rule. There's a multiplication there. It's x squared times y squared. So off to the side, I'm going to set up my product rule. So my x squared is my f. My g is my y squared. So the derivative of x squared is 2x. The derivative of y squared is 2y, but again, you have to times it by dy dx. You've got to think chain rule. A good rule of thumb when you're doing implicit, anytime you take the derivative of y, tack a dy dx on the end. So I'm going to set up my chain rule. I'm going to do 2x times y squared, or my product rule, sorry. And then I'm going to do x squared times 2y times dy dx. And all of that's going to equal the derivative of x, which is 1. Okay, so again, the goal is always to get the dy dx by itself. So all of that is being multiplied by the cosine x squared y squared. So I am going to have to divide this cosine x squared y squared to the other side. So I have 2xy squared plus, I'm going to pull the 2 in front of this, 2x squared y dy dx equals 1 over cosine x squared y squared. And so then I'm going to subtract my 2xy squared. So I have 2x squared y dy dx equals 1 over cosine of x squared y squared minus 2x y squared. So again, this is really just rules of algebra after the first step. You're just solving for a variable to get it by itself. So you have to think about solving any equation and how the rules of algebra work. And so then I'm going to divide the 2x squared y. So all of this is getting divided by the 2x squared y. So my derivative is this very complicated function, 1 over cosine x squared y squared minus 2x y squared, all over 2x squared y. Okay, so I want you to try 4 and 5. Pause the video, see if you can figure out these derivatives. Don't forget to solve for dy dx. When you're done, unpause the video and the answers will appear. Okay, here are the answers. Bring your questions to class.